reaction mechanisms. Again, it's on page 604 in your book. Y'all, what we've been looking at is really an overall reaction. For example, we might know that the reaction of two B's, I wrote that in the wrong order, A plus 2B makes D. Okay, that's our overall reaction. But what we haven't looked at and what we haven't talked about is that there might be a number of steps that have to happen in order for A plus 2B to make D. For example, you might first have to take A plus B and make C, and then that C reacts with other B's that are present to make D. That is a reaction mechanism. It's the steps in the reaction. Do you guys see how you take the A plus B makes C and C plus B makes D? Do you see how those add up to give you this that we have at the bottom? Do you see that these C's cancel out? And B's, since they're the same thing, they add together to give us two of them. Does that make sense? Kind of, sort of? Okay, these are called elementary steps. Y'all like that name? Elementary steps are simply the individual steps that happen to give you the overall equation. In this example, C has a special name. C is called a reaction intermediate. What is a reaction intermediate? It is something that is produced in one reaction, or I should say produced in one elementary step, and used in another elementary step, and doesn't appear in the overall reaction. Okay. Do I need to go back a slide? Okay. All right. That's our mechanism. Well, guess what? This mechanism, there are rate laws to this mechanism. Yay! Rate laws, y'all know, is equal to some constant K times the concentration of a reactant raised to the X power, and we have to look at experimental data, etc. Well, since these first two things are elementary steps, for an elementary step, the rate law follows the coefficients. You don't have to look at data. If you know you are dealing with an elementary step, then you would know that the rate law for this is going to be equal to K times A raised to the first power times B raised to the first power. How do you know that? Because I told y'all that is an elementary step. And for an elementary step, the exponents in the rate law will always be the coefficients. Okay? It just is. I told you that those first two are elementary steps. And if you know they are elementary steps, if you're told that, then the rate law, the exponents of the rate law, will always match the coefficients. So you also know, since this is an elementary step, you know that the rate law is what? Rate is equal to K times C raised to the first power times B raised to the first power. We know those rate laws all have exponents of 1 because both of those elementary steps have coefficients of 1. If something in there had a coefficient of 2, then I would have had to put the 2 on whatever that was the coefficient for. Okay? This last part, though, A plus 2B makes D, y'all, that's still your overall equation. You cannot use the coefficients for that one because it is not identified as an elementary step. You still have to look at the data like we were practicing on last time. Now, when you have different steps to a reaction, sometimes you have what can be referred to as the rate determining step. Rate determining step or rate limiting step. What would be the rate limiting step? How fast is it going? Don't you think exactly that the rate determining step is going to be the slow step? You know, it's like if you go over to our grill here and you get your hamburger and your fries really quick because there's 10 people serving hamburgers and fries, but there's one person checking the money, taking money. That it really doesn't matter how fast you get your burger, right? You got to stand in that line to pay for it. So that would be your rate determining step. That's your slow step. The slow step is always rate determining. The rate law for the slowest step or for the rate determining step will match the rate law for the overall reaction. How are you going to know which step's the slow step? Well, I'm going to tell you. So guys, look, if I tell you that this step is slow and this step is fast, you now know what the rate law for this equation is. What is the rate law for that equation? It is going to be rate is equal to some constant K times the concentration of A raised to the first power times the concentration of B raised to the first power.